we are going to learn about charging of capacitor. Already we have seen how a capacitor discharges. So we have a capacitor. What is a capacitor? Capacitor is two plates separated by a dielectric material or air. Now how can I charge this capacitor? So what I will do to make this capacitor charged, I will take electrons from one of these plates and put it in the other plate. So I am taking electrons from one plate and putting it in the other plate. So electron I am taking it from one plate and putting it in the other plate. If I do like this, charge develop across the capacitor. So from which plate I am taking out the electrons, that becomes positively charged. And which plate this electrons goes, which I have removed, that becomes negatively charged. This is how a capacitor gets charged, and it will be always equal. Positive charge as well as the negative charge is going to be equal. Now see, it is not possible to take the electron by our hand and put it to the other plate. To do that, what we do? The capacitor we will connect. With capacitor there is always going to be a resistor. We'll connect to a battery. So this is our RC circuit with a voltage battery is there, and there's one switch also there. Now this battery, what does it do? This will take the electron from the one of the plate and put it in the other plate. Instead of doing it by hand, now this battery will be taking care of that. So what happened? The electrons move from this plate to battery and reaches to the other plate. Now what is the direction of current? That is just opposite to the direction of electrons. At the instant we close the switch, the capacitor starts charging. And this charging of capacitor is governed by the equation. There is one equation, that is Q of t equals Q naught. Q naught is the maximum charge the capacitor can hold. 1 minus e to the power minus t upon RC. This is the equation. So this equation is you should know. So this is our circuit. Now we will see, while charging of capacitor, what happens to the current, what happens to the voltage, what about the voltage across the resistor, all those. Now we will see, I will draw some graphs. First, charge. So charge across capacitor QC with respect to time. What happens? The charge grows exponentially. Charge grows. It's an exponential growth. This is charging of capacitor exponentially. Charge is growing exponentially. So also we know the similar characteristics is followed by the voltage also, because voltage also rises slowly. This is what? Voltage across capacitor, and with respect to time. Then what happens to the current? When you charge a capacitor, the current exponentially decays. That means what? The maximum current flows I naught. The maximum current flows in the circuit at the instant when we turn on the switch. This with respect to time. So what is the maximum value of current that can flow in the circuit? That is I naught equal to what is the potential we applied upon series resistance. Now what about the voltage across the resistor? Voltage across the resistor. That is VR is the voltage across the resistor. With respect to time, what happens? The current is decreasing. Correct? Exponentially decaying. The current is exponentially decaying. So the voltage across the resistor also decays. So voltage and the current is having exponential growth. Current and the voltage across the resistor is going through exponential decay. Now let's learn about the time constants. We instead of going for charge, we will go for a voltage. Sorry. So on the y-axis we have voltage across capacitor, that is Vc, and the x-axis what we have? We have time. Now we'll draw the graph. Okay, it is not a perfect graph. Let me draw it once more. Okay, so voltage is rising exponentially. Now let us take the time period. At one time period, it has to be little more steeper. Okay, it has to be little more steeper, then only we'll get sorry. Okay, now let us take this as the first time period. 1 tau, that is the first time period. What is second time period? 2 tau. Then we have 3 tau. Next is 4 tau. And last one is up to 5 time period sufficient. 5 tau. Because all practical applications we consider capacitor gets fully charged at 5 time constant. Ideally it is not so. Ideally it needs infinite time. So the capacitor charges to 63.2% of V naught at one time constant, and the second time constant it is going to charge to 86.5%. 86.5%. These two time constant, it is better if you know. Okay, so here it is. So now I'll just write it as a table. One time constant up to what? One time constant, then 2 time constant, 3 time constant, 4 time constant, 5 time constant. What I am writing 1 tau, 2 tau, if you have seen my previous video, that is discharging of capacitor, you can follow this very easily. Otherwise please watch it. Okay, now this is same as Q also. Okay, QC also we can take it, the same graph. At one time constant, how much the capacitor charges? It charges to 63.5, 63.2%. 63.2% of maximum value of voltage. The next 86.5%, the 2 time constant of V0. Same is applicable for charge also. At 3 time constant, it will charge to 95% of V0. V0 is the, what is V0? The maximum voltage value. At 4 time constant, it charges it to 98.2% of the maximum voltage. Maximum voltage means what? What is the max voltage? It can get charged a capacitor, that is the supplied voltage. And at 5 time constant, it charges to 99.3%. And for all practical applications, we consider capacitor under steady state. After 5 time constant, the capacitor under steady state. That means what? It doesn't draw a steady state. I circuit current equal to 0. I wrote at steady state circuit current I equal to 0. So after 5 time constant, the capacitor doesn't draw any current, so it is under steady state. Right. I think this is sufficient. Okay. So in the previous video I told how to find how I am finding the 63% all this from the equation. Okay, from this equation we can find see what is tau here? Time constant, tau equal to RC. So in the previous video I have told you what is the R value. If you take 1 meg and 1 microfarad, what is the time constant? You will get 1 second. You will get 1 second. So by putting the various, see, instead of T you have to put, you can write RC also. The same equation you can write it, this is just as like this. Q of T or V of T equal to Q naught 1 minus e to the power minus, instead of T you have to put the time constant. So I'll write it in a voltage. That is V0 and V of T. This is the basic idea you need about the capacitor. How the capacitor gets charged, and what is the relation with this charging of capacitor with respect to time and the RC components. I hope these videos are useful to you. If so, please share with your friends and don't forget to hit the like button.